time t1, at any time t. So you want to calculate the velocity at any time t, not v1 value. Okay. So v can be written as a into t, and what is a? A is v1 by t into t. v1 by t1. This number is t1. So today's topic is power. So this is the last topic of the work power energy chapter. So power we have to calculate based on the force applied on the body. Okay. So what is power? Power is defined as the rate of work done. So there are two terms of the power. One is called the instantaneous power, another is the average power. So initially we will calculate the value for average power. So what is average power? Average power is the total work. Let us say W, delta W is the total work done. And in order to do that work, let us say delta T amount of time is being required. So average power delivered by the force is called basically the delta W by delta. So in the numerator it is work and denominator is the time. So work is joule and time is second. So joule per second is 1. So what is the unit for the average power? Okay. And when we calculate the instantaneous power, that means I have to calculate it in terms of the value which is delta W to be replaced by dW. Okay. So it is the limiting value of the average power as the time interval approaches to joule. So if I wait for delta T amount of time, it is a long time, then the power that we calculate is the average one. And if I reduce the delta T number to a small number dt, then that power should be equal to dW by dt. Okay. So that expression will be the value of instantaneous power. So that means main idea behind calculation of power is to calculate the work. So once I calculate the work number, then only I can calculate the power. So in order to calculate the work, there are two formats. One is the constant force. So if the force is constant, then I can write it as W equals to F vector dot S vector. Okay. And for variable force, I have to integrate it. For variable force, I have to integrate it. So for that, W should be equals to, or dW should be equals to F dot ds, and from that I have to integrate to get the value of total work done. So there are two formats to calculate the work. Either I can go for the first method or we can go for the second method. It depends on the problem. Okay. So in order to calculate the work, I have to calculate the first of all F dot S number or F dot ds number depending on the situation, and then I have to calculate the instantaneous power. Okay. So there are some expression that can be written for the instantaneous power is that if I say W equals to F dot ds, so ddt of F dot ds, where if I say F is constant, so F can be taken out of the differentiation. So we are left with F dot ds dt, and ds dt is velocity. So basically it gives the value of A vector dot velocity. So power can be written as F vector dot velocity vector when the force is constant. So work done by a constant force is F dot S. And at that situation only, I can write P equals to F V into cos theta. That means the theta is the angle between the force vector and the velocity vector. Okay. So if the angle between the force vector and velocity vector is known to us, so that means I can calculate the power as F dot V, and that is equals to F V cos theta. Since I am doing the dot product again, so it ensures that the P is a scalar quantity. P is a scalar quantity. And work done unit is joule per second. So that means the power unit is 1 watt or watt simply. Okay. So now I want to apply this formula to calculate the lifting of a water. Let us say there is a water and you have to lift it water with the help of a pump from the underground reservoir, let us say. Okay. So let us say I am lifting dm amount of mass of water. Dm is the amount of mass of water that has to be lifted from the ground to a certain height. So let us say height is h. That means in order to lift that dm mass, you have to impart the energy of dmgh on the mass because of the potential and everything. And another requirement is that you have to produce the velocity of the water as v. Okay. So corresponding to the kinetic energy of the water that I am lifting out, so that should be equals to half into dm into v square. Okay. So this is the total work done here. So in order to lift the water from the ground reservoir to a certain height of h and impart a velocity of v on that particular water, I need this much amount of work to be done. So correspondingly, can I calculate the power required for that? So P should be equal to dw dt. That means that is nothing but there only the variation is the dm. So dm dt into gh plus v square by 2. Okay. I am taking the dm number common. So dm dt is what? dm dt is called the rate of mass. Rate of flow. So that is the rate of mass flow. So that unit should be kg per meter, kg per second. So this is the unit is kg per second. So that means I should know what is the flow rate in kg per second. So for that you should know. So dmdt is basically defined is the parameter which is connected with the area. So let us say the area of the pipe is given, A is given. Okay. So at any time, let us say the particle or the water is crossing this area with a velocity v. So product of A into V. Product of A into V gives what? Product of A is meter square into V is meter per second. That means it gives the volume flow. This is called the discharge. So that means this is the amount of volume of water that should go inside. That means AV time volume. So corresponding to that, what is the mass flow rate? So M by T number or mass flow rate can be written as AV multiplied by the density of the water. Okay. So rho into A into V, that gives the information of M by T. What is M by T? M by T is the mass flow rate. That is nothing but the AV into rho. What is A? Is the area cross section. V is the velocity. V is the water is crossing that particular section, and rho is the density. Okay. So if these values are given, instead of giving the value of dmdt, you can simply replace the dmdt number with the value of AV into rho. Okay. So dmdt has to be calculated. So for dmdt calculation, the area may be given, the velocity may be given. So depending on that, you can calculate it. Okay. So whenever I am lifting this water from the ground, so let us say this is the water that is coming from the ground. So this water goes through a turbine, goes through a pump. So this is called the centrifugal pump. This is called the pump, centrifugal pump. So this pump is a mechanical device which will impart. So once the water go inside this, so these are called the blade of the pump. These are called blade. Okay. So once the water go inside this, the blade will work on this water to pressurize. Once the output pressure, so let us say PO is the outlet pressure and P is the inlet pressure. So in this situation, PO should be more than PI. So in order to increase the pressure at the outlet point, the pump has to do some kind of work. How the pump is doing work? By consuming some kind of energy. So inside the pump, I am supplying the electrical form of energy, and that energy is utilized to increase the pressure energy of the liquid. So once the pressure is increased at point outlet point, now this high pressure water can be lifted up and can fill this water. Okay. So basic operation of the pump is to increase the pressure. By way of increasing the pressure, it is able to increase the or it is used to lift the water from a ground level to the upper level. Why? Because water is not automatically flow. Why? Because at the bottommost position pressure is on the lower side. So I have to elevate it. So that means I have to increase the pressure. Okay, I have to increase the pressure. So in order to increase the pressure, the pump is. So pump is basically imparting a kind of energy, that is the pressure energy. So with that pressure energy, liquid is going to be lifted. So now you are asked to calculate the power of a pump required to just lift the water. Just lift the water means that you don't have to impart any kind of kinetic energy. So water is coming out with zero speed almost. So I am saying that no kinetic energy. So if no kinetic energy is being imparted on the water, then I should say the power is equals to only mgh quantity. So that is dmdt into gh. So if I say for this equation, the kinetic energy, that is extra part that has to be added with this, that number is okay. Now we have to define the efficiency of the pump. So what is the efficiency? Efficiency is output by input. So as an input, I am supplying some kind of electrical energy. Okay. So this energy is the input form of energy. So now as an output, I am getting the mechanical form of energy or the pressure energy. Okay. So this energy, how much amount of energy that I am getting out of it, or let's say pressure energy. So this energy, this ratio is known as the efficiency of the pump. So in some situation, you are asked to calculate the efficiency of the pump, how much efficiency is required. So output power that has been developed by the pump, that is basically utilized to replace this. So this output power is utilized to lift the water. So output power is nothing but the power of the pump required. But since the input power is more than output power, so there must be some efficiency value. Let us say the pump is, so first of all, we calculate the, let us say 20 watt of power is required, let us say, to lift the pump. That is a P output. But If the pump is supplying 20 watt to the water, then it will not create. Why? Because pump is a mechanical device. There is some kind of loss inside the pump. So let us say the pump has to produce a power of, let us say, 30 watt. That means this is the input power of the pump. Okay. So that means that now I can understand what is the ratio of the input to the output, or I can calculate the efficiency of the pump as 20 by 30. Okay. So that number has to be calculated. Or in the other way, so this number once you calculate corresponding to that, if the efficiency value is given, so you can calculate how much amount of power input is required for the pump itself. Okay, so both way the question can be asked. Either you can calculate the input power or you have to calculate the output power. Okay. Now let us say there is a block which is resting on a floor, which is friction, which is having some kind of friction, and I am applying a force of 30 Newton on that particular. So this is the constant force. The constant force. So you are asked to calculate the power delivered in 2 seconds. So that means at 2 seconds, I am to calculate what is the velocity. If I calculate the velocity, then power should be equal to F dot V. So in order to calculate the velocity after 2 seconds, what I have to do? So on this body, so what is the limiting friction that can act? Limiting friction is equal to mu into N. That is 0.5 into 20 means 10 Newton. So since the limiting friction is less than the applied force, so that means the body will move. Okay, so first you have to check whether the body can move or not. So I calculated the limiting value of friction and I got the result as 10 Newton. That means the body will move now. So once the body is moving, so let us say at this direction, in this direction, you are applying a force of 30 Newton and there is a friction force acting opposite as 10 Newton. So for this 2 kg mass, net force is 20 Newton. So acceleration of the 2 kg will be 30 minus 10 by 2. That means 20 by 2 means 10 meter per second square. So with 10 meter per second square, what is the velocity after 2 seconds? So particle start from here. Now it will move with an acceleration a equals to 10 meter per second square in the forward direction. And ultimately the particle will go up to this position where the velocity should be equal to u plus 80. Okay. If I take u is 0 because the particle starts from rest, so simply a into t. So a is 10 and t is 2. That means 20 meter per second. So this is the velocity, that is the particle achieved after 2 seconds. So corresponding to the what is the power? So power is basically a vector dot v vector. Now here the force and v are both in the same direction. So that means theta is 0 degree. Okay, simply write F into v. So F is 30 and v is 20. That means that is equal to 600 watt. So this is the power delivered by this 30 Newton. Now similarly, out of this 30 Newton, so out of this 600 power, some power is already consumed by this 10 Newton friction force. Why? For the friction, force is opposite direction of velocity. So power consumed by the friction. So this is the power produced by the capital F. So power consumed by the friction, if I want to calculate, that should be equal to minus 10. 10 is the limiting value of friction. Multiply the velocity. Velocity is how much? 20. So that means minus 200 watt. So this is the amount of power that has been consumed. Okay. So power is produced up to 600 Newton and the consumption is around 200 Newton with a negative sign. Okay. So again, you have to take care about the direction of the force and the velocity before calculating the power. Okay. Now moving on to the next item. Let us say there is a car which is running with a constant power. Okay. So in the earlier question, I have said that the force is constant and correspondingly, I am getting the power is constant only. Now it is given that the car is running with a constant power. Why the car is running? Because engine is applying some kind of force. Let us say Fe is the engine force. Okay. So this is the force due to engine. So engine is offering some kind of force. Because of that, the car is moving. So you are said that the power by the engine is constant. So engine is developing a constant power every time. Now you are asked to calculate the speed of the car as a function of time, assuming the car starts from rest. That is again you are equals to 0. Okay. And on this road there is no friction. So only force that is acting is the engine force. So corresponding to the, can I say, acceleration produced by this engine force should be equals to F E by M. Okay, that is the acceleration produced by this. So in time t, the velocity should be how much? After time t should be equals to a into t. Okay, so velocity after time t should be equals to u plus at. Now since I am getting a is constant, so I can write 0 plus a means fe by m into t. Okay, so this is the velocity produced. Okay, So once I got the velocity information, so depending on the velocity, can I write the power produced by the engine can be written as Fe into V. Okay. So Fe is how much? Fe into V. So that means Fe is Fe square by M into T. That is the power. Okay. That is the power. So now you are asked to calculate the velocity as a function of time. So instead of writing Fe, so you replace it with V. So here, from here I can write Fe number should be equal to Vm by T. So put it over here. So V square M square by T square divided by M into T. So ultimately I am getting V square M by T. Or I can write V should be equal to Pt by M whole root. That is the answer. Okay. So this is the velocity as a function of time. Okay. So simply I have to calculate the power. So power is equals to what? Force into velocity. Force is what? Force is the engine force. So once I calculate force into velocity, so I am getting Fe into V. V is equals to Fe T by N. So Fe into T by N. So Fe square T by N. Okay. So that expression in this question there will be two parts. So one part is P equals to Fe square by M into T. So from here I can write the expression for the engine force as a function of time. That is Pm by T under. Okay, that may be another answer. And I am also calculating, instead of calculating Fe4, I can also calculate the velocity. So I got the velocity expression as under root Pt by M. Okay, so both can be asked. So how much amount of engine force is being applied, or what is the corresponding velocity? Okay, so this is the variation of velocity. Now let us say this is another type of problem which is similar to the vertical circular motion. So you are asked to calculate the tension in the string after the mass m equals to 5 kg falls down at the particular instant. Okay. So let us say that initially the particle is hanging over there, so which is at rest. Now once it is coming down, so it encountered a pin. Let us say there is a peg fitted on the wall. So once it touches the peg, so then around the peg it will start to move along a vertical circle. Okay, along a vertical circle. The total length of the string is 10 meter. So peg is at a distance of 5 meter below this fixed point. So from this point, a circle of 5 meter radius will take place. Okay, circle of 5 meter radius. Now you are asked to calculate when the particle is making a 37 degree with the vertical, what is the tension inside the string. Let us say at this point the particle is moving with a velocity of v. With a velocity of v. Corresponding to this v, the mv square by r force will be over here. So what is R? R is 5. I am writing directly 5. And mg is there. Vertically downward. So if this angle is 37, this angle is also 37 degree. Okay, so mg cos 37 component will be added up. So mg cos 37 means 4 mg by 5. And that should be balanced by the tension force acting in the opposite direction. So in this direction the tension is acting. So I can write T number should be equals to 4 mg by 5 plus mv square by 5. So I have to calculate the v value, then I have to put it over here, that will give the value of tension. So in order to calculate the v value at this position, I will take the work energy conservation between the point A and point B. Let us say this is the B point. So drawing a horizontal line from B, I am saying this is the reference line. I am allowing the energy conservation from point A to B. Again the concept is like this way. So whatever is the work done by tension and the centrifugal force, that is basically 0. Why? Because both of these two forces, work done by tension and work done by centrifugal force, these are going to be 0. Why? Because the displacement direction and the force direction are perpendicular to each other. Okay. So only thing I have to write the potential energy and the kinetic energy. So if I write initial potential UA, kinetic energy is K at point A, that's equals to UV plus KB. Okay. Now Ka is 0. Why? Because the particle is released from rest from point T. So kinetic energy is 0. Now what is UA? UA is nothing but the, so I have to calculate this amount of height. Okay. So one height is, this is 5 meter. This height is 5 meter. Okay. Another is 5 cos 37. So this height is what? 5 cos 37, because this angle is 37 degree. So 5 cos 37 means 4 meter. Okay. So UA is mg into h. H is 4. So 4, h is 9. So 5 plus 4 means 9. So 9 mg. Okay. kinetic energy is 0. Now potential energy at point B, because B is lying on the reference line, potential energy is 0, and I want to calculate the kinetic energy, that is half m v square. Okay, so A main cancels out, so v square becomes 18 G. 18G. So I put this number over here. So ultimately I am getting 4 mg. M is 5. Given as 5. So 50 by 5 plus 5 by 5 into v square. V square is 18G. Okay. So there come 40 plus 180. 220 Newton. Okay, 220 Newton is the tension at this point. Okay. So this is a case of simple vertical circular motion. When the particle is coming from point A, it hits a peg, and once it hits the peg, it starts to fall, it starts to go around another circle of radius 5 meter, and you are asked to calculate the velocity at that particular instant. Okay. So moving on to the next equation. Now the particle is projected with a velocity of root 3 GL from a point A, lowest point. In the vertical plane, find the maximum height above the horizontal level about point A. So I know that if the particle is projected with a velocity of root 5 GL, because it is connected with a string, so this is a string part. So I know that if the particle is projected with a velocity of root 5 GL, then it will complete the vertical circle. If the particle is projected with a root 2 GL velocity, then it will go up to that particular point, pendulum motion. So since the particle is projected with a velocity of root 3 GL, that means it will go up to a certain height, which is in between the maximum point and the horizontal point. So let us say the particle go up to this point. Let us say this is the point B. Okay. So I know the vertical angle the point B makes, that expression is cos theta, that should be equal to u square minus 2 GL by 3 GL. Okay. Now if I put u square value as 3 GL, so 3 GL minus 2 GL by 3 GL, that means 1 by 3. So cos theta becomes 1 by 3. So if cos theta becomes 1 by 3, now you are asked to calculate what is the height between these 2 points. How much height will rise? So this height is how much? This height is basically L cos theta. L cos theta means L by 3. And another height is L is there. Okay. So total height should be L plus L by 3. L plus L by 3 means 4L by 3. So it will rise up to a height of 4L by 3. 4L by 3 from the maximum point. 4L by 3. So this is the answer. Maximum height above the horizontal level above point. So options are not written clearly, not proper. 4L by 3 will be your answer. Okay. Not 40L by 27. It is 4L by 3. Answer is 4L by 3. So this should be your answer. So this is the height above the horizontal from point A. So this is the point A from where the particle will be projected. Let us say there is a body of mass 1 kg is projected with a velocity of 5 meter per second from the surface of Earth at an angle theta equals to 60 with the horizontal. So this theta is 60 degree with the horizontal. This is being fired. What is the power delivered by the gravitational force at the following instant at M at the highest point? Now you are asked to calculate the power by the gravitational force at the highest point. So at highest point mg is acting downward. Nah. And I know that at the highest point only the x component of velocity is there ux. So force dot velocity. So this is the force vector. This is the velocity vector. So power developed by the mg force is how much? F dot v. But the angle is 90 degree. Okay. So power equals to F dot v. But angle is 90 degree. So what is happening? Then 0. Okay. Understood? Okay. Now you are asked to calculate the same number when at point N. At point N, once the particle is moving down, so if I throw the ball with the u velocity, it will come down with the u velocity in this direction. Okay. Now u has two components. One is ux, another is uy. So once the particle is hitting the ground, so uy is downward and ux is horizontal. Okay. Yes. What is uy? Because vehicle is fired with a velocity of 5 meter per second. So uy is 5 sin 60. So 5 root 3 by 2. And it is 5 by 2. Okay. Now out of ux and uy, I can see clearly that uy is parallel to the mg force. Because you are asked to calculate the power delivered by the gravitational force. So mg is parallel to uy. So only mg will give the power, mg will give the power, but ey will give the power, ux will not give the power. Why? Because ux is perpendicular to mg. Okay. So power by mg is equal to how much? Only mg into uy number. So mg is 10. Mg is 10, mass is 1 kg. Into uy is 5 root 3 by 2. So 25 root 3 is the answer. What? Nah, 25 root 3. Understood? Because in this, when the part is hitting the ground, mg becomes parallel to uy and mg becomes also perpendicular to ux. So since force becomes perpendicular to velocity, so ux has no power component. Okay. Now the power is variable. Okay. So power is given by this number, where t is in time second. The change in kinetic energy between the time 2 seconds to 4 seconds. 2 seconds to 4 seconds. So I know that power equals to dw dt. Now power equals to dw dt. So total work done change, that should be equal to p dt. So w net. So integration of dw will be the total work. W net. That should be equal to integration of p dt. Nah. So integration of p dt means 3t square minus 2t plus 1 dt. Limit is from 0 to 2 to 4. 2 to 4. Okay. So first answer is 3 t cube by 3 minus 2 t square by 2 plus t. Now limit I am putting from 2 to 4. So first is 4 cube minus 2 cube minus t square means 4 square minus 2 square plus 4 minus 2. Okay. That is the joule. So total work done. So it comes to be as 4 cube means 64 minus 8 minus 16 minus 4 plus 4 minus 2 means 2. 64 minus 8 is 56 minus 12 plus 2 means 10. So that means 46 joule. Okay. 46 joule is the total change in energy. Now you are asked to calculate the change in kinetic energy. From work kinetic theorem, I know that W net total work done is equal to delta kinetic. Okay. So I have already calculated the net work done. So that is the answer for the change in kinetic energy. So total kinetic energy change for the part is now 46 joule then. Okay. Now try to do this one. So blades of the windmill sweep out a circle of area A. Okay. If the wind flows with the velocity, in this direction, let us say the wind is going with the velocity v, perpendicular to the circle. What is the mass of air passing through the in this time? Yes. So the area of cross section of this is A. So through this area of cross section, the wind is passing. So I know that mass of the airflow in time t, that is m by t, should be equal to rho times A into v. Okay. Yes, sir. So these are asking the total mass. So m should be equal to how much? Rho A v into k. Okay, that is the answer. Come to this one. So body of mass m accelerates uniformly from v1 raised to v1 in time t1 as a function of time t. Okay. The instantaneous power delivered by the body. So there is a mass which will accelerate uniformly from raised to v1. Raised to v1 in time t1 as a function of time t, the instantaneous power. So that means the acceleration is constant. So what is the value of acceleration? Acceleration is equals to v1 by t then, because it will start from rest. Okay, so this is the acceleration produced by the particle. So corresponding to the acceleration, that means the particle moving in this direction with an acceleration. Okay, that means some force is acting over here. So force should be how much? Force should be equal to mass into acceleration. So A into g1 by t is the force acting on it. Okay. So correspondingly, what is the instantaneous power? So power should be equals to force into velocity. So velocity is basically g1. V1 is at any time t1, at any time t. So you want to calculate the velocity at any time t, not v1 value. Okay. So v can be written as a into t, and what is a? A is v1 by t into t. v1 by t1. This number should be t1. Why? Because the information is given for 0 to t1. Okay. So into this is T1 into T. Okay, so that is the velocity. So correspondingly, what is the power? So power is equal to force. Force equals to A into V1 by T1 into velocity at any time T. That should be equal to V1 by T1 into T. So ultimately, your answer should be A V1 square by T1 square into T. That will be your answer. A V1 square, T1 last option. Okay. So particle is moving with some acceleration. So information is given regarding the acceleration that the particle accelerates from 0 to V1. So from 0 to V1, the acceleration takes place in time T1. Corresponding to the acceleration is known as V1 by T1. Okay, V1 by T1. But you have to write the power as a function of T, not T1. Okay, that means you should calculate the velocity V as a function of T only. So what is that velocity? That is equal to simply A into T. A into T. So I have written the A value multiplied by T number. Okay. Now come to the next one. So man is riding on a cycle with a velocity of 7.2 km per hour up a hill having a slope of 1 in 20. Slope 1 in 20 meaning is that if I say this is alpha angle, so sine alpha is given as 1 by 2. Or you can simply write tan alpha of that number also. And that is approximately tan alpha. So why? Because it is very small angle. Okay. The total mass of the man of the cycle is 100 kg. The power of the man is. Okay. So man is riding with a velocity of 7.2 km per hour up a slope. Okay, up a slope. So in this situation, let us say is the man. So mg sine alpha is acting downward. Mg sine alpha is acting downward. Now the particle is moving in this direction with velocity 7.2 km per hour. 7.2 km per hour means 7.2 into 5 by 80 meter per second. So 80 into 7.2 means 0.4. 0.4 into 5 means 2. So 2 meter per second. Okay. Now calculate the mg sine alpha number. So this is the force. Against this force, the man has to work. So man is climbing means man has to apply another force which is equal to mg sine alpha in the opposite direction. Okay. Because mg sine alpha is trying to pull the man downward. So I have to apply another extra force. That means the power is equal. So this force should be equal to again mg sine alpha number. Okay. Now what is that force? F should be equal to mg. M is given as 100 kg. 100 into g is 10 into sine alpha is 1 by 20. Okay. So 20 into 5 will be 50. 50 Newton. So correspondingly 50 Newton. What is the power delivered? That is 50 into 2. So power should be equal to force into velocity. That is 2. 100 watt. Okay. That is your answer. Understood?
Yes.
That's it. So this is the entire chapter of the work for it. Okay. So I have completed the entire chapter. Okay. Now your turn is to practice. So once you practice, then only you can understand. So in the next class, I will take some of the problem regarding the work for it. On the work for it. Okay. Before that, you must cover the entire part. Okay. We will do this again. If you have any doubt, ask me in the next class. But I will solve the numericals from various topics on the work for energy. Okay, application of work energy. Because work energy concept is very important to understand. With this concept, you can solve different types of problems. Okay. So you have to read it carefully. If you have any doubt, then ask me in the next class so that I can solve. Now, in this situation, there is a windmill which is converting 25% of the total wind energy into the electrical form of energy. So, area of the cross section of the windmill is given A, V of the air flow that is given, density of air is also given. So, you are asked to calculate the electrical power production. That means, through this section, the air is coming. Let's say through this section, the air is coming of sectional area of A. The velocity of particle of air is V. So I know that mass flow rate of air, m by t of air should be equal to how much? Rho A into V. Okay, this is the amount of mass of air in 1 second that is being flowing. So kinetic energy of air in 1 second. In 1 second. Okay, how much? That is equal to half into m into v square. So I know that m is how much? M is basically rho a v in 1 second. So it gives half into rho a v into v square. That means rho a v cube by 2. That is a kinetic energy in 1 second. And kinetic energy in 1 second is nothing but the power developed in 1 second. So this is the power by air. Okay. Why? Because this is the work done per minute time. Work done is nothing but kinetic energy. So work done divided by time. So I am taking the time as 1 second. So this is called the 1 second trick, where you are applying the 1 second method to calculate the kinetic energy that has been developed in 1 second. That is nothing but your power. But in the question, there is given that the windmill is only converting 25% of this. Okay. So output power is how much? Output power is 25% of input power developed by the air. That means ultimately it is P by 4. So 1 by 8 into rho a v cube. That will be your answer. Okay. 1 by 8 rho a v cube. So 1 by 8, rho is given as 1.2. Area is how much? 30. And v cube means 10 cube. So 10 to the power 3. Okay. So ultimately I am getting 1.2 by 8 into 30 means 12 into 3 by 8 into 10 to the power 3. 4 2 is 8. 4 3 is 9 by 2 means 4.5. So that is 4.5 into 10 to the power 3 1. So that will be your answer. So this is the amount of power in the form of electrical energy being produced by this windmill because of the energy conversion. So how much amount of energy is being converted? Only 25%. Rest of the 75% is basically lost. Okay. So your answer is option number B then. Now in this question, there is a machine gun which fires a bullet. So 60 bullets are emitting per minute. So that means if I say 60 number of bullets are emitting per minute, so in 1 second, so number of bullets should be equals to 1. Because 60 bullets per minute divided by 1 minute in 60 seconds. So that means this 1. So 1 bullet is emitting in 1 second. So with a velocity of 700 meter per second. With a velocity of 700 meter per second. So if each bullet has a mass of 50 gram, you are asked to calculate the power developed by the gun. So in this situation, what happens? So every time you have to consider this type of problem in 1 second. So I calculated the value of number of bullets in 1 second. So if I say the kinetic energy of one bullet, kinetic energy of one bullet is how much? Then equals to half mv square. This is the kinetic energy gained by the one bullet. Okay. So if I say this is the basically the work done by gun. So gun is doing what on the bullet so that the bullet is getting the kinetic energy. So number of bullets emitting in 1 second is 1. So work done by the gun per unit second, 1 second. That is basically the power by the gun. That should be equals to how much? That should be equals to simply half mv square into number of bullets emitting in 1 second is 1. So that is your answer. Half mv square is the power of the gun. So half is half. M is 50 grams means 50 by 1000 into v square means 700 into 700. Okay. So ultimately what happens? So 1000 into 1000 cancels also 5 into 7 into 700 by 2. What? So 30. So it is 5 into 7 means 5 into 7 into 350. So ultimately I am getting that 122,501. So this is the answer. That means this is the amount of power developed by the gun. Okay. So in this type of problem, every time you have to solve it on the basis of 1 second. How much is the work is being done by the gun in 1 second. So that will give the basically the power of the gun. Okay.